Welcome back, boys and girls. We are going to talk about special cases today. So yesterday we talked about factoring quadratics or trinomials, where you got three terms where a is either 1 or a is greater than 1. So remember your general form, ax squared plus bx plus c is the general form for a quadratic. Today we're going to look at special cases throughout this. After I'm done with this video, I'm going to make another one for tomorrow that's going to talk about like how to do each one. It's going to have a flow chart that you can kind of follow along and go from there just to help you out. So first of all, we're going to look at patterns today. Make sure you understand how to apply each pattern and explain why the pattern might work or it will not work for a quadratic. So first, we're going to look at perfect square trinomials. So when are you going to use this? We're going to use this when you see perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, yada, 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 until you see perfect ones. So make sure you're familiar with those. The way this works is x squared is just x squared, 4 squared is, it's not 4, 4 squared is not 4, 2 squared is 4. Then if your parentheses, so what you're going to do is you're going to take 2 times the parentheses, and if that equals there, it's a perfect square trinomial. So you're going to look at the first term. Is it a perfect square? Yes. So x squared. Is the last term a perfect square? Yes. 2 squared. If you add those together, or multiply those together, multiply by 2, you get 4x. So yes, it is. So your 2 parentheses, x and 2, are going to be your perfect squares. That's going to be your binomial that factors. So perfect square trinomial is always going to factor into a binomial that is squared. It is a perfect square. So if I look at another one, because I know I went kind of quick through that, x squared is x squared. 49 is 7 squared. It'll always be a positive in the back. So 2 times x times 7, does that equal 14? Yes. The only difference here is this is a minus sign. So we're just going to subtract the 2 parentheses, so x minus 7 squared. If you FOIL it out, once again, to check your work, you can always do this with quadratics. So x squared minus 7x plus 49. You see you get where you started because negative 7 plus negative 7 is 14. Sorry, negative 14. So these are perfect square trinomials. They are nice and simple if you see the pattern. So x squared, 1 squared, 2 times x times 1, yes. It's a plus sign, so x plus 1 squared. Just really quick here, if I show you the x factor, I got 1, 2, factors of 1 to add to give you 2, 1 and 1. So you see you would get x plus 1 and x plus 1, same thing. If I did my chart, a times c, 1 times 1, plus in the back give you 2. So 1 and 1 give you 2, so same thing, x plus 1, x plus 1. Well, that got real bad. So if you forget the perfect square trinomial, you can factor it the long way and it's still going to work. Now over here, 2 is not a perfect square, neither is 18. But you got to recall, the very first thing you always do is GCF. And now you have an x, you have a 3, 2 times 3 times x, doesn't matter, 6x, so you're good here. So that's a minus sign, so x minus 3 squared, bring down your GCF, and you are good. I know I went through that quick, pause it, watch it more than once, but remember, if the first one's a perfect square and the last one's a perfect square, you got a good shot. Rewrite them, multiply by 2, if that gives you the middle term, you are good to go. All right, difference of squares. If I have a perfect square and a perfect square, that is always going to factor into a plus b, a minus b. Everything has to be perfect squares for this to work. So 1 is a perfect square. 4 and x squared are 2 and x. So I got 1 minus 2x, 1 plus 2x, and I'm done. These are great. These are nice and easy to use. Now b over here, a little bit bigger, don't freak out. As long as the exponent is even, you got a great shot. So p to the fourth squared minus 7q to the third. 49 square root is 7. 7 squared is 49. 6 divided by 2 is 3. So I have p to the fourth minus 7q to the third, and then p to the fourth plus 7q to the third. And you got an easy way to factor these. All right, this one. I see I have a whole bunch of stuff. It is a perfect square right now. Please don't do it right away. Please pull out the GCF. Always look for that first. In 16 and 4, I can take out a 4. I can also take out an x squared. So that's going to leave me with a 4 minus x squared. Now 4 is 2 squared. X squared is x squared. So I got a 2 minus x, 2 plus x. Doesn't matter what order. Bring down your GCF. And you have it completely factored. I messed up there. It's not 2x minus. It's just 2 plus x. I'm going to rewrite that for you. And you are good to go. So that is your difference of squares. Know your formula, you're up there. Now, sum of squares is the exact same thing, but I'm adding them, so I have to throw in the i's. So a plus bi, a minus bi. The i's will allow you to get that plus sign. It's a nice little trick that helps you allow. Previously, if you've learned factoring before, you can't factor the sum of squares. Now that we know i's, we can. So it's the exact same way. So that's 1 squared, that's a 2x squared. It's a sum in the middle. So I'm gonna go 1 plus 2xi. All you're doing is adding the I at the end. 1 minus 2xi. When you FOIL that out, it looks a little weird. I promise you it factors back to what you started with. You can try to FOIL it out and cancel and see what you get. Now over here, excuse me. GCF time, they're both even, so I got at least that, but I know I can take out a 4, so that's gonna leave me with a 4x squared plus 25. So I got a 2x, and I got a 5x, so I have a sum of squares, so I'm gonna leave my 4. So 2x plus 5i, it's always with the second term. 2x minus 5i. So you should have a plus and a minus the terms with the I. All right, and then lastly over here, 9x to the 4, so that's 3x squared. 49 is 7 squared. That's real bad. So 3x squared plus 7i, and then 3x squared minus 7i. So you got your perfect square trinomials, you got your difference of squares, and you have your sum of squares. So now let's take a look at these. Determine which determine whether each trinomial is a perfect square. If so, explain it. If not, then yes. So, is x squared? Yes. Is 4? Yes. 2 times x times 2 again. I get 4x, so yes, this one's good. So x minus 2 squared. Is this one right here? No. It has to be a plus in the back. For it to be a perfect square, you cannot have a minus back there. It doesn't work out because you can't have 2 times 2 give you a -4 or -2 times -2 give you a -4. They have, since you're multiplying the same thing twice, it's always going to be positive. And over here, this last one, first one checks off. That checks off, so 2 times 3x times 2. 2 times 3 is 6, times 2 is 12x, so yes, it works. So minus the 3x minus 2 squared. So those are the biggest differences in those two. All right, determine whether each binomial is a difference or sum of squares. So first one, x squared minus 24. No, 24 is not a perfect square. 25 would be, 16 would be, but not 24. S squared plus 4 squared. Yeah, they're already factored for you. So S is a perfect square. 4 squared is already written for you, nice. It's a sum, so S plus 4i and S minus 4i. Very good. This one over here, 27 is not, 3 is not, but we're trying to trick you here. Let's take out a GCF. If I can take out a 3, 9x squared minus 1 So now, is 9x squared? Yes, I can take that 3, oh, not a cubed, I said 3 and wrote 3, I should have written a 2. 1 is a perfect square always, so I'm good here. So it's a difference of squares, so 3x plus 1 and 3x minus 1. So there's kind of a quick synopsis of your special factoring cases. You got your perfect square trinomials, your difference of two squares, and your sum of two squares. All right, error analysis. 2 students found which one is incorrect and which one is correct. So here, if I look at the first one, I got a little wonky. So 25 is a perfect square. So if I'm walking through this, so that's gonna be 5x squared squared. So I see right here, I'm forgetting this. So that is what is wrong with those. There should be a square and 3y squared, and I also need a y there. Homeboy screwed up a lot. Over here, so which one is right? This one is right, A is not. So kind of walk through that, checking up, make sure you are good to go. Sometimes the instructions will ask you to solve. It's just taking it one step further, or sometimes they'll ask for the roots of the equation. Please note there are several names that you should get. What you're doing differently is once you factor it, you're gonna set each equation equal to 0 and solve. So you're gonna see one of 4 things. These will be used interchangeably, so you need to be familiar with them all. So solutions, roots, intercepts, zeros, they all mean the exact same thing. So what we're going to do, if we're going to solve this equation, this quadratic equation now, because there's equal signs by factoring. So I'm gonna go ahead and set it equal to 0. And then I'm gonna look at my flow chart, figure out how to solve it. This is just a normal one. So I'm gonna build my chart. So what factors to 28? Minus in the back, so subtract to give me 3. 7 times 4. So x minus 7, x plus 4. Negative 7 plus 4 is negative 3, so that checks out. So that's factoring, that's where we should be at. Now the only thing you need to add now, it's equal to 0. So set each part equal to 0. Each parentheses gets a 0, and then solve. So I'm gonna add 7, so x equals 7. I'm gonna subtract 4, and x equals negative 4. If you take both of those solutions, plug them back in, you should get 0 every time. All right, this one, find the roots of this one. So I'm gonna set it equal to 0 first. So I'm gonna move that 60 to the other side. So 30x squared minus 5x minus 60 is now gonna equal 0. Now there's a big number, so I'm gonna look for GCF. I can take a 5 out. So that's gonna give me a 6x squared minus x minus 12 is equal to 0. So now I'm gonna come over here and do my chart. So 6 times 12. So take a second, 6 times 12, you get 72. Minus in the back, so what factors is 72? Subtract to give you a 1, so that's 9 times 8. So remember that is going to be x minus 9, x plus 8. I'm gonna divide those by 6 because that was my A term. That 5 is the GCF, it's tagging along. So x minus 3 over 2, x plus 4 over 3, kick them up. So when this is done factoring, I'll move this up a little bit for my hand. So I got 5, and then I got a 2x minus 3, and I got a 3x plus 4. So now I'm gonna set each part equal to 0. So 5 equals 0, 2x minus 3 equals 0, 3x plus 4 equals 0. 5 doesn't equal 0, so I'm done there. If you have an x as a GCF, that's where that's gonna come into play. Now I'm gonna solve this. So move that 3 to the other side, so 2x equals 3. So x equals 3 halves. Move that negative 4 to the other side, so that becomes a negative 4. Divide by 3. And I got negative 4/3. So I have my solutions here. Find the roots, just a different way to work. So it's adding that one more step in there. All right, got a couple more, then we're almost done. So find the intercepts here. This one's nice. You can either factor it or you can solve it. I'll do it both ways. So this is a difference of squares. So x squared minus 4. So x squared, 2 squared. So they are perfect squares, so you get an x plus 2, x minus 2, set each part equal to 0. So x equals -2 and x equals +2. Shorthand, if you see this, it's just 2 terms. This is easier to do. Move that 4 to the other side. And now you can take the square to both sides. Just remember, anytime you take the square to both sides, you get 2 answers. All right, last one. So solve g of x. So if I'm going to solve this, I'm going to set that equal to 0. So here I see the first terms are perfect square. Last terms are perfect square. 2 times x times 6 does give me 12x. So x plus 6 squared. Now I'm doing it twice. So all you have to do is set one of them equal to 0 because you'll get the same answer. And we'll talk about multiplicity later, but this would have a multiplicity of 2 because it would occur twice, and that comes into play when we're graphing. But right now you just got one answer. So last thing, what is the difference between factoring and solving? Factoring, you just break it down. Solving, you're gonna set it equal to 0 and get a solution. So factoring, my answer is gonna look like this. We're gonna have something here. This, you're gonna have a variable equal to something. So that is the difference in the two. So I hope you have a good day. Enjoy this. Tomorrow we will summarize everything and get ready for our quiz.